All right, real quick, here are the answers to C and D. You set u equal to the denominator of both fractions in both integral problems, and then you have to manipulate them a bit. Like here, you need, if your u is going to be x squared plus 2x, and then your du is 2x plus 2 dx, well, you only need x plus 1 dx up here, so you have to factor out the 2 from 2x plus 2, and then that creates x plus 1 dx, so you would have to divide by 2 to the other side. And then you get 1/2 du equals x plus 1 dx, so that integral turns into 1/2 du over u, which is really just, when you do the integral of du over u, it's just natural log u. That 1/2 is a constant multiple in front, and then you plug back in your u, and you get your final answer. Same thing over here. You have to divide by 3. After you find your u and your du, you have to divide by 3 to get it consistent with what's in the integral. Let's look at example E here. So now, your u here, you might think you're going to set u equal to the entire denominator, x ln x, but then when you do du, you'd have to use a product rule, and that would get way too messy, and you're going to have a lot of extra stuff in your du that you don't need to account for in your original integral. So here, you have to actually just set your u equal to ln x. That's it, because when you do the derivative du of ln x, so the derivative of ln is just the derivative of the inside of the ln, which the derivative of x is just 1, over what's inside of it, x. And then you tack on your dx there. So du equals 1 over x dx. Well, that is this. See that 1 over x dx that I just circled? That is your entire du statement. So this integral becomes du over u. This thing right here, this ln x right here, is your u. This whole red thing that I circled, 1 over x dx, is your du. So this integral really just boils down to du over u, which we know the integral of du over u is natural log of u plus c. And then last step is plug back in your u expression. So ln of, but u is also another ln. So this becomes like an ln inside of an ln, is what this is. And this was an actual problem on your last quiz I mentioned before. You had to do the derivative of ln x, and you wound up with this 1 over x ln x example. I think it was like number 6 or 7 on your last quiz. But that's it. All right.